All right. Hey guys. Video number 2 for the day. We're going to talk about solstice and seasons here. I've had some major technical difficulties today, so I apologize. Camera's not working. Also, we've had internet outages and power outages today, so it's been super fun around here. Hopefully, it'll stay screen sharing because it did not in my last attempt to do this. So, all right, today we are looking at seasons. All right, we just discussed moon phases, we discussed um, tides, spring tides, neap tides, and we also discussed eclipses, solar eclipses, and lunar eclipses, and how all of that is because of Earth, Moon, Sun alignment. Solstice equinox seasons, okay, this has a lot to do, right, with that alignment. It's very important to that alignment, but this is more about Earth and Earth's tilt, okay? So standards here, still 1-1. Obviously, when we're talking about seasons, we're talking about solar radiation and the influence that it has on our planet specifically. We're still also talking about orbiting objects in the universe because if the Earth did not orbit the sun, then we wouldn't have the opportunity to have seasons. So that those two standards there are still very much applicable to what we're talking about. All right, seasonal differences we talked about with when we talked about Unit 4 atmosphere, right? We talked about all the places around the Earth that do have 4 true seasons, and also in those temperate climates, right? We also talked about some places that do not. This is going to really give you a great um, perspective as to why, right? A good perspective as to why that is the case. What's the main cause of the seasons? We have seasons, and you're going to see this question. This is a test question. This is a quiz question. You're going to see this a lot. It's on the benchmark. What is the reason for seasons? And the answer is because Earth's axis is tilted. Earth's axis, right? That invisible line that goes from pole to pole. It's not straight up and down. If it was, we would have a very different world. It is tilted at 23.5 degrees, and that 0.5 there is actually what gives us leap year. So 23.5 is the tilt of that axis. What does that cause? Well, it causes a difference in direct and indirect rays from the sun. And as you probably can imagine, direct, think about that solar radiation directly on the Earth or any point of the Earth is going to do what to those temperatures, right? The direct rays are going to give us that heat up, right? It's going to get hotter. The temperature is going to go up. And if you can imagine, think about what season really correlates with direct solar radiation and higher temperatures, okay? Also, at the other side of the revolution, we get what's called indirect. And this happens for both North and South Pole. So Northern Hemisphere and Southern Hemisphere. And so we get on the opposite side here, as you can see on the bottom, this is where the north is getting indirect. Those rays are coming in, and instead of just beating down on us like they are at the top picture, right, they're actually glancing off the surface. And again, think, what season would that correlate with? Think about indirect solar radiation, and what is that going to do to temperatures? Okay, so the tilt of the axis is the reason for the seasons. Here we have, and this is for the northern hemisphere, but we have the axis you can see, and a major thing I want to point out to you when people are doing this diagram, oftentimes they move the axis. The axis never changes what direction it is pointing to, okay? So as you can see around this, let me get my, can I annotate here? Surely. Oops, we'll do that. I don't really know why I can't annotate. Oh well. All right, so if you're looking at the axis, maybe you can see my mouse. I hope so. Earth's axis is pointing, right? Same direction here as it is here, as it is here, as it is here. It's pointing towards Polaris, or the North Star, okay? And that never changes. So if you ever get a diagram, or you're drawing a diagram, or you're working through a diagram, and that axis is flipped, you know that it is inaccurate, incorrect, and you cannot get your correct answers if you do that. or if you have a diagram like that. So that axis is the first thing I check when I look at a diagram like this, and it's always pointing in the same direction, always tilted the same direction. Again, you can see that we are just slightly off kilter. So this is straight up and down. You can see that with the half of everything is light, half of everything is dark. What the sun hits there, so you can see that line perfectly, and you can see just a little bit tilted there at 23.5 degrees. That tilt does a lot. You can see up here in the northern hemisphere that sun is pounding down on the earth right there. It's direct radiation. It is heating up. That is June, okay? That's our summer month there in June, summer solstice. You can see down here in the south is the opposite. So whatever happens in the north, the opposite happens in the south. So down here in the south, you can see that the axis is tilted away from the sun. Those rays are hitting and bouncing off of the earth here, and it's getting indirect radiation, which means that June, for our southern hemisphere friends, is winter, okay? The shadows are kind of confusing here for September and March, but as you can see here at these two, right, top and bottom Earth, we have the axis is neither tilted towards nor away. And so we get moderate radiation, moderate temperatures, and that's our spring and our fall, which makes sense, right? And then over here, the northern hemisphere is tilted away, okay? So the rays are coming in and glancing off the surface of the earth there, giving us lower temperatures. Indirect radiation, lower temperatures, that's winter. And the southern hemisphere is now tilted towards the sun. So for our southern hemisphere friends, they're coming around to their summer vacation, right? December, summer vacation. I don't know if their school does that or not, but summertime in the south. The seasons, like I just said, are not the same for everyone. Northern hemisphere and the southern hemisphere are opposite of one another because of the tilt, right? So let's take a look at that radiation that I was just talking about. This is just an example, okay? You got light coming in, you got it glancing off the surface there, talking about light coming in for Earth, solar radiation glancing off, and temperatures are going down. If that light is hitting that source directly, then those temperatures are going up. Same is true here for the Earth. So take a minute, pause it, see if you can figure out what season, looking at this image, what season do you think the Northern Hemisphere is in? The crazy thing is, if you know what the North is in, you know what the South is in. So take a pause just a minute there and see if you can guess. Hopefully you paused it. You can see that solar radiation is beaming down on the northern hemisphere. That is direct solar radiation. Those temperatures are going to increase. That tells us it's going to be summer. You can see it. Well, we automatically know, right? Intuitively, if it is summer in the north, it is winter in the south. But you can also give an explanation for that, right? Because we're very intelligent. You can give an explanation for that. You have the solar radiation coming in, glancing off of that surface. It is not direct, or it is indirect solar radiation, which of course gives us the winter months in the south. The tilt of Earth, this is so confusing sometimes for kids. Day and night is controlled by Earth's rotation. We spin once on our axis, right, every 24 hours. However, the tilt also controls the length of day. Think about that as we're moving towards, I know, because we're playing ball, right? We're playing baseball right now at this time in softball. So my kids' practices are moving back further and further and further and further. Why? Well, because the days are getting shorter. Okay, so at night we used to be in the summertime. It wouldn't get dark till like 9 o'clock. So we have blackout shades on every window in my house because nobody will go to sleep with it being so bright. But that's happening because of the tilt of the axis, right? The length of day is affected. And if you just think about that, guys, in the summertime you can play outside till 9 o'clock. It's awesome, right? And then in the wintertime, though, it gets down about what, like 5 o'clock, 5:30, and it feels like it's time to go to bed, especially after the time changes, right? So the length of day is affected by the tilt of the axis, okay? The poles are different, so sorry, I had to pause because the dogs are barking. So at the poles, this is different. During the summer months at the poles, the sun almost never sets. Can you imagine it being? I know you guys have watched maybe a movie about Alaska, and you can see that So that phenomenon happens there, but it almost never sets. It's like day all the time, 24 hours. And then in the winter months, though, it almost never rises. So, I mean, can you imagine what that kind of life would be like without the sun for 24 hours, for, I mean, a couple months there. So it's pretty crazy. The midnight sun is a phenomenon that occurs in summer months north of the Arctic Circle or south of Antarctic Circle when the sun doesn't set. Despite the extraordinary daylight, the following picture was taken at midnight in Barrow. Again, that's midnight. Can you imagine how cool or frustrating that phenomenon might be? All right, so we got two vocabulary words here that you need to know. You need to know solstice, and you can see if you break that word down, just like solar, right? Solstice, sol means sun, el sol, it means sun. And so solstice means when sun is at its most or when sun is at its least, okay? So the day that has the most sun is called the summer solstice. That is our longest day of the year, around June 21st, sometimes 22nd, okay? But summer solstice in the northern hemisphere occurs June 21st. That is the longest day of the year. This is also the winter solstice in the southern hemisphere. Winter solstice is the shortest day of the year. Again, the most sun or the least. So in the northern hemisphere, winter solstice, first day of winter is December 21st, shortest day of the year. And you can see here why that is. We get direct radiation in the summer. Okay, we're tilted towards. We've got longer days, hotter temperatures, direct rays. And the opposite is true for the south, right? So that's June 21st. Opposite of that's December 21st. So all the way across the spectrum over here is our winter solstice tilted away. And you can see the amount of light. Like, look, half of everything is light, half of everything is dark. Look at that. Look at how much of the northern hemisphere has light. Over here, look how little has light. And so you can get a good visual there for why the tilt affects daylight hours. Equinox, that root word there, equal, right? I'm sure if you said that out loud, you're probably, oh, that sounds like equal. Equinoxes occur twice a year, just like solstice, but it occurs when we have equal day and night. And I bet if you're thinking right now, you're thinking, oh, I bet this time also has moderate temperatures. You'd be right. Okay, so we have two equinox. Equinox means equal, and nox means night. Equal day and night. Okay, so about 12 hours a day and 12 hours of night. And we get those two in fall and spring. Makes sense, right? Makes sense? It's equal day and night. And we get those 12 hours. Okay, so March 21st, sometimes 22nd, September 21st, sometimes 22nd. Okay, we get this equal day and night where we get this one day where it's equal day and night. So first day of spring, March 21st, 22nd, first day of fall, September 21st, 22nd. Okay, equal day and night. And those are across from each other. And again, if you know what's happening in the northern hemisphere, then you can certainly answer what's happening in the southern hemisphere. And I think that's about all for our seasons, actually. All right, good. Bring your questions to class. The practice, repetition on these seasons, these diagrams is wholly important to being able to get it. Again, it's like riding a bicycle for this information. Once you got it, yeah, you got it forever and ever. Amen. All right, guys, bring your questions to class. Thank you for your attention. See you soon.